I want to start today by asking you to just visualize something that is probably sitting in your house right now.
Right.
Maybe it's on your windowsill or, maybe it's in the corner of your living room. Just look at one of your potted plants. You see the green leaves, the stems, the way it catches the light.
The whole presentation.
Exactly. Maybe a flower if you're lucky. That's the part we curate. That's the aesthetic layer.
Yeah, in tech terms, that's the user interface.
Right. The UI. It's the shiny front end that we, post on Instagram. But let me ask you this. How much thought do you actually put into the server room underneath?
Oh, the container.
Yes, the container, the engineering of the vessel itself.
And I don't mean like, does this terracotta pot match my mid-century modern credenza? I mean the actual physics, the fluid dynamics of the environment where the roots live.
Yeah, if you're like me, the answer is zero thought. I mean, you assume a pot is just a bucket.
Right.
A bucket with a hole in the bottom if you're being responsible. You put the dirt in, you put the plant in, you water it, and you just sort of hope it survives.
Which is wild when you think about it.
It is. But today, we are going to completely dismantle that assumption. We are doing a deep dive into a really fascinating, specific piece of writing that argues the standard flower pot is, well, it's basically broken technology.
Yeah, it's a hardware failure. A legacy system that is long, long overdue for a patch.
So true. We are exploring a blog post titled Notes on Gardening.
Part 806.
Part 806, yes. Exploring Ventilated Pot and Polybag.
Yeah.
It was published just recently on February 13th, 2026. And the author is a guy named Eng, writing at qianmeng.org.
And can we just pause on the title for a second? Part 806.
Right.
This isn't just a casual weekend update. This is rigorous. This is a long-running documentation of a system. It's a devlog.
That is exactly the vibe. Because Eng doesn't call himself a botanist. He doesn't call himself a landscape architect or a plant daddy. He introduces himself with a very specific, very evocative title. He calls himself an old software plumber.
I absolutely love that framing. Software plumber. It implies a very specific worldview.
Tell me about that.
Well, a plumber looks for leaks, right? They look for blockages for efficient flow. And a software engineer or a software plumber looks for bugs. They look for inefficiencies, for legacy code that needs refactoring.
And that is exactly what this deep dive is about. It's about what happens when you take that debugging mindset, that really rigorous systems thinking approach, and apply it to a living organism.
Yeah, Eng isn't just growing a plant. He's trying to optimize a biological system.
Right.
He's looking at a dying plant, and he's not seeing, bad luck or because I don't have a green thumb.
He's seeing a stack overflow.
Exactly. He's seeing a resource management error, and he's looking for the root cause, pun entirely intended.
Yeah, pun fully appreciated. So our mission today is to unpack Eng's discovery of what might be the perfect flower pot. We're going to learn about a mechanism called air-pruning, which honestly completely blew my mind when I read it.
It's a game changer.
It really is. And we're going to see why the standard black plastic bag you get at the nursery might be the gardening equivalent of running your business on Windows 95.
It's legacy infrastructure.
Yeah.
And as we'll see, it's causing critical system crashes.
Let's start with the crash. Let's start with the bug that Eng is actually trying to fix here. The core problem is something pretty much every plant owner dreads. You buy a beautiful plant, you water it, you love it, and then one day, the leaves turn yellow.
The stems get mushy.
Yeah, and it just melts.
Root rot. It's the silent killer. And the tricky part is it happens entirely underground. It's in the dark, so you don't even see it until the system has already failed.
It's catastrophic data loss.
Truly.
Eng specifically focuses on a group of plants called aroids.
Right. And these are the trendy ones right now. If you open any interior design magazine or scroll social media, this is what you see.
Like what specifically?
Oh, monsteras, philodendrons, alocasias. They are those really beautiful sculptural plants with the big leaves. But biologically, many of them are epiphytes, or at least semi-epiphytes.
Okay, unpack that term for us, epiphytes.
So in nature, they climb trees, their roots are exposed to the air, they're clinging to bark, getting rained on, and then drying out almost immediately.
Oh, so they aren't buried.
Exactly. They don't sit in dense, wet mud at the bottom of a swamp. They are structurally designed for massive airflow around their roots.
Eng actually calls them notoriously fussy about their feet being wet.
Which is a great way to put it. When their roots sit in stagnant moisture, they suffocate. Anaerobic bacteria basically take over, and the roots literally turn to mush.
Yuck.
Yeah. But Eng identifies a structural cause for this. It's not just about, overwatering because you got too enthusiastic with the watering can. It's about the shape of the root system inside a standard pot.
This is where the engineering analysis kicks in. He talks about the circling root. I think we really need to paint a vivid picture of this for the listener. What actually happens inside a smooth-walled, standard plastic pot?
Okay, so imagine a single root tip growing. It pushes through the soil, looking for water and nutrients. It's genetically programmed to just extend, go further and further out.
Right.
Eventually, it hits the wall of the pot. Now, plastic or glazed ceramic, that's impenetrable. The root can't go through it.
So it has to make a choice.
Right. And since it can't go through, it turns. It hits the wall and just slides along it. So it's going in a circle.
Because the pot is round.
Exactly. And because it never finds a way out, it just keeps circling. Round and round the bottom of the pot.
Aang describes it as a single long root circling the bottom.
It's like a car stuck in a roundabout with no exits.
Yeah.
It's expending all this energy. It's technically growing, but it's not effective growth. It's just creating a tangled mess down there.
It reminds me of looking behind my TV stand. Just that massive knot of cables that you can't even begin to untangle.
That is the perfect analogy. It's cable clutter. But in a pot, that clutter is deadly. Because think about it. Where does the water go when you water a plant?
Gravity pulls it straight to the bottom.
Right. So you have this thick, tangled cable of roots sitting right in the wettest, darkest, most stagnant part of the entire container.
So that is the vulnerability.
That is the security flaw in this system.
Mm-hmm.
That circling root sits in the muck, it rots, and because it's one long, continuous strand, the rot just travels up it like a fuse, and then the whole plant collapses.
Wow, so it creates a single point of failure, one long root rots, and the whole plant loses its main intake valve.
Precisely. It's just bad architecture. It's a design flaw in the container itself.
Okay, so Aang is looking at this. He's the software plumber. He sees the bug. He sees the circular dependency, literally.
Literally circular.
And his first instinct is the maker instinct. He mentions in the post that he initially considered just grabbing a drill and punching holes in his existing pots.
Which is the classic patch approach. You have a broken system, you don't have the budget or the time for a full migration, so you force a fix. You just hack the hardware yourself. It's very DIY engineering.
But then he stumbles upon a manufactured solution. He finds a product that has this patch basically pre-installed. He calls it a variation of the aroid pot or ventilated pot.
And this is where we get into the actual engineering solution.
Yeah.
The difference isn't subtle at all. A standard pot is a solid wall. These ventilated pots look almost like a basket or a cage.
Yeah, they have slits or holes running all the way down the sides, not just at the bottom. Aang shares a photo in the post. It looks incredibly porous.
It does.
It looks like it wouldn't even hold water well, which I guess is exactly the point. It looks like a laundry basket for dirt.
That's exactly what it is. It creates a totally different physics environment. It changes the hydrology entirely. The water drains out the sides immediately.
So no more wet feet.
Right. But the most important thing it does actually isn't about water. It's about how the roots interact with the air. Which brings us to the core concept of the entire article, the mechanism that actually fixes the bug. Air-pruning.
Air-pruning. I have to admit, when I first read that term, I pictured Aang going in with tiny scissors and trimming the roots through the little holes.
I think a lot of people picture that. But no scissors involved. The air itself does the cutting.
We really need to slow down and explain this because this is the technical heart of the whole deep dive. This is the code update that fixes the circling root bug. So walk us through it step by step. What happens when a root hits that hole?
Okay, let's go back to that root tip we talked about. It's growing through the soil, extending outwards from the center of the plant. In the old pot, it hit the solid plastic wall and turned sideways, creating that infinite roundabout.
The infinite loop.
But in this ventilated pot, the root grows outwards and hits nothing. It hits a hole. It is open air.
And then what?
Biology takes over. Root tips are incredibly sensitive to humidity. They absolutely need moisture to survive and push forward. When that really delicate tip hits the dry outside air, outside the pot, it dehydrates. It desiccates.
So it dries up.
It dries up. The tip effectively dies.
So hold on. For the average listener, the root dies sounds like a major system failure. I mean, we want the plant to grow. Why are you framing this root death as a feature and not a bug?
That is the counterintuitive brilliance of plant physiology. And this is where the software analogy is just perfect. Think of that single circling root as a single-threaded process that is completely hung up.
Okay.
It's using all the system resources, the plant's energy, but it's not maximizing the connection to the soil. It's just getting longer and longer wrapping around itself.
So it's a waste of energy.
A total waste.
Okay, so the tip dies. What happens next?
When the tip dies, the plant receives a hormonal signal. It loses what's called apical dominance on that specific root strand.
Apical dominance.
I like
it sounds like,
corporate jargon.
yeah. It sounds like a middle management term.
It basically is middle management for plants.
Huh.
It's the boss saying, keep going forward, team, just keep extending. But when the tip hits the air and stops, the signal changes. The hormonal signal effectively says, okay, this path is a dead end. We cannot extend any further in this direction. We need new pathways.
So it triggers our redirect.
Exactly. The plant redirects its energy. Instead of lengthening that one useless strand, it starts shooting out lateral side roots from the center of the root mass further back up the stem.
So instead of one long string, you get a spider web.
You get a complex network. Eng describes the result perfectly in his notes. He says you get a massive, healthy, and fuzzy root system.
Fuzzy. It's a very specific word. Why fuzzy?
It's a great visual. Those fuzzy bits are the root hairs. Those are the actual microscopic intake valves for the plant. They're what actually absorb nutrients and water. By air pruning the tips, you are forcing the plant to stop building one long highway and instead create a dense, efficient network of thousands of tiny absorption points, rather than just one long, useless cable wrapping around the bottom of the pot.
So if we go back to the software plumber idea, a root-bound plant is a single cable that's tangled and super inefficient. An air-pruned plant is what?
It's distributed computing.
Wow.
It's load balancing. You have a mesh network of thousands of small connections. It is a significantly more robust system. Think about it. If one tiny root tip rots or fails now, you have 500 others to take the load. If the single circling root in a normal pot rots, the whole system goes down.
That is incredible. It's amazing that just changing the container, just adding some holes to the hardware, triggers this massive physiological change in how the organism literally builds itself.
It's nature adapting to infrastructure. You change the constraints, and the system optimizes for the new environment.
Now, this is where the deep dive gets really interesting to me, because Eng doesn't just write this post to say, hey, ventilated pots are great, go buy them. He's a tinkerer. He starts observing the specific design of the hardware he found.
Right, he's looking at the specs. He's not just checking the feature list. He's inspecting the build quality.
Exactly. He notes a very specific difference in the shape of the ventilation holes. He says that the standard ventilated pots, the premium ones you might see in a high-end nursery or strictly online, they typically feature long rectangular slits, like vertical slots running down the side.
Correct. That is the industry standard design for maximizing airflow. You see these often in specialized orchid pots, too.
But the pots Eng found, and he seems to have sourced these locally, maybe as a cheaper variant or just what was available to him, they have smaller circular holes. It looks like someone took a standard hole puncher to the side of a plastic cup.
And immediately, the engineer in him wakes up. He's skeptical. Or at least he's opening a ticket for it. He writes, I'm curious whether these smaller, circular holes offer the same air pruning efficiency as the standard ventilated pots.
But why would the shape matter? I mean, a hole is a hole, isn't it? If the air gets in, the root stops.
Well, not necessarily. Think about the surface area and the probability involved. A long vertical slit creates a really large kill zone for the roots. No matter where the root hits that vertical plane as it circles, it's highly likely going to encounter the air gap.
Right, you can't really miss a floor-to-ceiling slit. It acts like a firewall.
But a pattern of small circles. There's solid plastic between them. It's like a perforated sheet.
So there's a chance the root could just navigate between the holes.
Exactly. The root hits the solid plastic between the circles, turns, and starts circling all over again. It might miss the air pruning trigger entirely.
Oh, see.
Or consider the airflow dynamics. Maybe the air exchange through a tiny circle isn't as rapid as a long slit.
So the dehydration isn't instant.
Right. If the dehydration is too slow, the root might not prune itself at all. Instead, it might just push right through the hole and keep growing into the open air, just hanging there, outside the pot like a sad string.
Which totally defeats the purpose. Now you have roots dangling outside the pot, drying out, but not triggering the lateral branching inside where the soil actually is.
Right, it creates a completely different kind of mess. So Eng is identifying a potential design flaw in the budget hardware. He's asking, is this optimized, or is this just a cosmetic imitation of the function?
It looks like it should work, but the math might be wrong.
Precisely.
So he has a hypothesis. And true to his title, he proposes a real test.
He does. He says, perhaps we can get a few and experiment with different plant species. He's going to run A/B testing right in his garden.
I love this guy. He's treating his garden like a development environment. He's going to deploy the plants into 2 different hardware configurations and see which one crashes and which one scales.
It shows that he understands that optimization isn't a binary state.
Right.
It's not just ventilated or not ventilated. It's how ventilated, what shape, what density. It's the nuance that makes him a true software plumber and not just a casual gardener. He wants the actual data.
So we've got the problem, root rot. We've got the premium solution, ventilated pots with slits. We've got the budget test case, ventilated pots with circles. But then Ang brings in a third player, the legacy system, the polybag.
Ah, the humble polybag. If you've ever bought a plant from a nursery, you know these. They're those black, crinkly, super cheap plastic bags.
They are everywhere. And Ang points out that theoretically, they are trying to do the exact same thing. They have little holes punched in them.
They do. The logic is the same, drainage and air.
Mm-hmm.
Ang actually calls the polybag the economical version of the ventilated pot.
But he is definitely not a fan.
No, he marks them as deprecated.
He says polybags still often lead to plants becoming root-bound. Why is that? If they have holes, why doesn't the air pruning work? Why is the patch failing on this specific system?
It comes down to structural integrity. A rigid pot holds its shape. The air gap on the outside is guaranteed. But a polybag is flexible. It crinkles.
It collapses on itself.
Exactly. Think about wet potting soil. It's really heavy. It pushes the bag out. If you pack a bunch of polybags together tightly on a nursery tray, or if the bag just folds over because it's flimsy, those punched holes get sealed shut against each other.
Right?
Or the root grows along the side, hits a fold in the plastic, and just keeps sliding along that smooth channel without ever hitting the air.
So the hardware is too buggy, the interface isn't stable enough to guarantee the function.
The infrastructure is totally unstable. Even if the intent of the design is air pruning, the execution fails in the real world. The root doesn't hit air, it hits a fold of black plastic, so it circles.
We're right back to the roundabout.
We're back to the bug. The polybag is fine for transport, it's like a temporary cache, but it's not a production environment. You shouldn't run your live code, your permanent monsteris, in a polybag.
Don't run production in a polybag.
I feel like that's a maxim that applies to a lot more than just gardening. It sounds exactly like something a senior dev would yell at a junior dev.
It really does. It's about investing in the foundation. You can't build a skyscraper on a swamp, and you can't grow a massive, healthy aeroid in a crinkly, collapsing bag. So Ang essentially concludes that the rigid ventilated pot is the superior hardware upgrade. It permanently patches the security vulnerability of root rot.
It provides a stable, predictable environment. And for an engineer like Ang, predictability is everything. You want to know that if you execute the water plant command, the physics of the pot will handle the excess perfectly. You want to know that the roots are being managed by the architecture, not just left to chaos.
It's absolutely fascinating how we've gone from a simple, short blog post about buying plastic pots to a masterclass in system architecture.
Well, that's the power of the software plumber lens, isn't it? Ang isn't just accepting the status quo that plants die sometimes. He's asking, what is the mechanical failure point?
And he's willing to tinker. He's willing to question the standard.
It's the iterative mindset. Observation, hypothesis, testing. He observed the circling roots, the initial bug. He hypothesized that side ventilation was the key. Now he's testing the circular holes versus the slits. It's the scientific method applied to the backyard patio.
And honestly, it forces us to rethink what growth actually looks like. That's the part that I'm still stuck on.
What do you mean?
Well, we tend to think that bigger and longer is always better, right? Like, look at that long root. We celebrate linear progress. But Ang is teaching us that sometimes you actually need to stop the linear growth to get the robust lateral growth.
That's profound insight. You have to hit a wall, or in this case, an air gap to branch out.
Yes. The dead end is actually the catalyst for the system becoming significantly stronger.
Precisely. If the root never faced that limitation of the dry air, it would just keep spinning in circles until it eventually rotted. The limitation created the strength. The pruning created the abundance.
It's almost like constraint-based creativity or resilience training.
It really is. A system with absolutely no constraints often becomes bloated and inefficient. But a system that has to adapt to limits, that becomes complex and resilient.
I think that's a lesson we can all take away, honestly, even if you don't own a single houseplant.
Absolutely. Efficiency isn't always about speed or length. Sometimes it's about density and connection. The network is stronger than the single thread.
So true. So, as we wrap up this deep dive into Aang's notes on gardening, I want to leave the listener with a final thought to mull over. We've talked a lot about hardware and bugs and plastic pots.
Let's hear it.
We spend so much time curating the part of our lives that everyone else can see: the leaves, the flowers, the shiny parts, the UI.
The public-facing front end, the LinkedIn profile, basically.
Right. But the success of that entire system depends entirely on the dark, hidden architecture of the roots, and specifically how those roots interact with the invisible element of air.
The back-end infrastructure, the stuff nobody sees but everything relies on.
Exactly. So my question to you is, where in your own life do you have circling roots? Where are you putting massive amounts of energy into a single, long, tangled path that's just spinning around in the dark, effectively going nowhere?
Wow. That is a powerful question. Where are we being root-bound? Where are we just repeating the exact same pattern and expecting a different result?
And maybe more importantly, where do you need a little bit of air pruning? What is the invisible air, that deliberate friction or hard boundary that you're sealing yourself off from?
Yeah.
Where do you need to hit a hard stop, let that path terminate so you can actually start branching out laterally and building a real network?
Sometimes you need to stop extending to start growing.
Beautifully said. Maybe we all need to check our containers.
Indeed. Maybe we need to drill a few holes in our own routines.
Huge thanks to Aang at kianmeng.org for this fascinating spark of an idea. It's a great reminder that you can find incredible wisdom in a cheap plastic pot if you look hard enough, and if you bring that plumber's mindset.
Absolutely. I'll definitely be thinking about software plumbing every time I water the ferns this week.
Same here. Thanks for listening to The Deep Dive. Go check your pots, people. We'll see you next time.
Take care.